Hello everyone, welcome back. Let's talk about another easy problem on Leetcode today. Single number, Leetcode 136. In this problem, we are given a non-empty array of integers, nums, where every element appears twice except for one, and we have to find that single one. We must implement a solution with a linear runtime complexity and use only constant extra space. Then in example 1, for the given nums array, the output is 1 because the array contains the elements 1 and 2 occurs twice and 1 occurs only once, so that is why 1 is our output. Similarly, in example 2, nums contains the elements 1, 2 and 4 where every number except 4 occurs twice, therefore the output is 4. Now, in terms of solution, one way to solve this problem, given that we need to check for duplicates, is to use a data structure called a hashset. Then we can just iterate over each element in an array, and if the element is not in the hashset, we add it. But if the element is already present, then we can remove it. And in the end, the hashset will contain only one element that appears only once, and that will be our answer. For example, for the given array in example 1, first we see number 2, so we add it to the hashset. Then we see 2 again, so we remove it from the hashset. Then we see 1, and as it is not present in the hashset, so we add it to the hashset. And now that we are done with all the elements, only 1 remains in the hashset, so 1 is our answer. The time complexity of this approach is O of n, where n is number of elements in the array because we are iterating through the array once. However, the space complexity is also O of n because in the worst case, we may be storing n by 2 elements in the hashset. And the problem challenges us to solve it in constant extra space. This means we need to be more space efficient. So another way to solve this problem is to use sorting. By sorting the elements, all the duplicates will naturally come together in pairs. For example, when we sort nums array in example 1, it becomes 1, 2, 2. Or if we sort nums array in example 2, it will become 1, 1, 2, 2 and 4. Then we can compare adjacent elements in pairs. And whenever we find a mismatch, that element will appear only once and hence that will be our answer. And if we go through the array without finding any mismatches, the last element in the array must be the single number. For example, for sorted array in example 1, we compare elements 1 and 2 in pair, and because they don't match, we find a mismatch, so we will return 1 as our answer. Similarly, for sorted nums array in example 2, we again compare elements in pairs. So we compare 1 and 1, they are same. Then we compare 2 and 2, they are same. Now there are no more pairs to compare, so the last element 4 is the single number. Now the space complexity is O of 1 because we are doing everything in place. However, the time complexity now becomes O of n log n due to first sorting the elements and then comparing them in pairs takes O of n times. So overall the time complexity is O of n log n, and again we have to solve this problem with the linear runtime complexity, that is in O of n time, and that too with only constant extra space. And now the question is, what can help us achieve that? The problem statement specifies that every element appears twice except for one element. So is there a way to cancel out these duplicates without using any extra space? And this is where XOR operator can help us because of its unique property that XOR of a number with itself is 0. And why does this property hold? For that, let's look at XOR at the bitwise level. When we XOR 2 bits, the result is 1 if the bits are different and 0 if the bits are the same. For example, 0 XOR 0 is equal to 0, 1 XOR 1 is equal to 0, 0 XOR 1 is equal to 1, and 1 XOR 0 is equal to 1 as well. The reason this holds true is that at a bit level, XORing a number with itself cancels out all the set bits, resulting in all 0 bits, which is equal to number 0. Therefore, if a number occurs an even number of times, they will all cancel out to 0. And if the number occurs an odd number of times, only one instance of that number will remain. For example, XORing the number a 4 times will result in 0. However, XORing the number b 3 times will result in b itself. Also, XOR is commutative and associative, meaning the order of the operations does not matter. For example, if I do a XOR b XOR z, the result will be same when I do a XOR c XOR b. Similarly, if we do a XOR b XOR a, the two a's will cancel out, leaving us with only b. So when XORing the numbers, the order of operations don't matter. Another property that will help us is XORing the number with 0 will result in the number itself. This holds true because at the binary level, 0 has all its bits as 0, And XORing any bit with 0 will keep the bit set as it is, like XORing 0 with 0 results in 0 and XORing 1 with 0 results in 1. So given this, we can also set our initial result as 0. So now our approach can be that we iterate through the array once, XORing all the elements. All the paired numbers will cancel out, leaving the single number as the final result. Now let's see this in action with some examples. Let's take a generic example first with nums as a, b, c, b, a, where a and b occur twice and c occurs once. So we can XOR the elements as follows. Initially, we can take our answer as 0. So first number we see is a. So we will do 0 XOR a, which will be equal to a itself. Then we see b and XOR it in the result as well. Then we see c. We XOR that also into the result. Then we see b again. And this time when we XOR b with the result, b and b will cancel out to 0, leaving a XOR c. And finally we see a again. And this time when we XOR a with the result, a will cancel out, leaving the element c, which will be our answer. Now let's look at this at the bit level as well. Let's take example 2 for that. We know that binary representation of 4 is 100, 1 is 001, and 2 is 010. So let's write these numbers down in their bitwise representation. First number we see is 4. So we write down 100, 1 is 001, 2 is 010. Then we see 1, which is again 001, and finally 2, which is 010. So now we perform the bitwise XOR between them. So this is bit position 0, this is bit position 1, this is bit position 2, and so on. So at the 0th bit position, we see that there are two set bit counts, which is an even count. So XORing them will cancel them out, resulting in 0 at 0th bit position. Then at first bit position, we again see that there are two set bits, which is again even, so they will cancel out and we will again get 0. And finally at the last position, we have only one set bit, which is odd, so we will get 1 as our output here. So we are left with number 100 in binary, which is 4 in decimal. So this identifies a single number, which does not repeat. Now the time complexity is O of n as we traverse the array once, and the space complexity is O of 1 since we are using constant space to XOR the elements together. Now let's jump into the code part. First, let's initialize our answer to 0. This variable will accumulate the XOR results. Now we will iterate through each number in the nums array and perform the bitwise XOR operation between the answer and the number and store the result back into the answer. And by the end of the loop, all the pairs will have cancelled out, leaving us with a single number that is our answer. So we will return it back. Now let's submit this code. Cool. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.